Today's problem is zigzag tree, traversal, difficulty medium. Given the root of a binary tree, you have to find the zigzag level order traversal of the binary tree. In zigzag traversal, we traverse from left to right for odd numbered levels and right to left for even numbered levels. Okay. Let's see, what does that mean? Right to left for even numbered levels. Okay, so I guess we're going to count this as 1. Because this one is going right to left, right? 1, 3, 2, 4, 5, 6, 7. Okay. This one is going where? This one is going 7, 7, 9, 8, 8, 6, 9, 10. Number of nodes will be between 1 and 10 to the 5th, 100,000. The data in the nodes will be between 1 and 100,000. Expected complexities O of n, auxiliary space O of n. Yeah, we need well, we need a queue for this, and then we need a list to compile the answer as well. Company tags, a lot of companies there. Traversal tree. Okay. Yeah, you should really know how to do this. Why do I say that? Well, because a lot of companies ask the question. That's one. I mean, two is it's just a breadth first traversal, which is a basic traversal for trees and graphs. What else? This is also on lead code. Although it's a little bit different on lead code. On lead code, they want you to return a list of lists. So every level gets returned as its own list. It doesn't make it any harder. It's just a slightly different output format. All right, so let's look at this. I would like to, okay, yeah, that's fine. Can we see everything here? Almost. You know what I'm going to do here? Let me just try taking out some of the lines that are in here for spacing and see if we can get the entire yes. Okay, if we do that, that's what we want to see. We want to see down to where the reverse changes. Okay, that's fine. All right. Well, let me grab a pen and show you how this works. I mean, so to do a breadth first search, we would use a queue. Now, if we're going to go back and forth, we can use a deque, a double-ended queue, and that will let us queue things from either side of the queue, front or back, and it'll let us deque things from either the front or back. All right, so let me grab a pen here and see if we can sketch this out. Actually, you know what? I don't really want to. I don't want to use that one. Let me use this. Oh, come on! Really? I just signed in yesterday. All right, forget that. You know what? It's all right. Let me just pause it for a second. Okay, actually, before we start drawing things, note here that we have a list. That's the result. We have a deque. We add to the deque the root to get things started, and we have a variable here called reverse, which is initially false, right? So let's see. Queue, well, the queue, so we're going to be adding things from like both sides, I guess. Let me just put the queue. Initially, we're going to queue a 1. Right? Let me do this. Where can I put that? Let's just put that here. Reverse equals initially false. All right. And then scroll it up. Can we see everything? Yes. All right. While the queue is not empty, which it's not. And I is going from 0 to level size. Well, the queue size, okay, the queue size actually is 1 at this point. So we're going to go from 0 to level size node. If reverse, well, reverse is not true. Node, queue, poll. All right, so node is going to equal the 1. Result, add node to the data. So let's see, that'll be the queue. And then the list we can put here. So we'll add to the list a 1. All right, good. If reverse, no, it's not reverse. Else, if node left is not equal to null, which it's not, it's 2. Q, add node left. All right, so we've actually popped this. Q, add. All right, node left. So that goes in here. If node right is not equal, and it's not, so we add the node right. So that would be a 3. Okay. Drop down here. Let's see, the 4. Okay, so we are out of the for loop now because the for loop went from 0 to the level size, which is 1. So we're going to change reverse. Reverse is now true. All right. We're out of that. Back up to the top. Is the queue empty? No. Level size is the queue size. Well, that now is 2. Okay, so we're going to go two times through the for loop. If reverse, well, reverse is true. So node is poll last. That is this 3 here. Result, add node data, so we would add 3. Okay. If reverse, now reverse is true. All right. Let's go ahead and we were supposed to remove that, right? Yes. Okay. If reverse, reverse is true. Now, does 3 have a right hand node? Yes. So add first 7. Okay. So the 7 goes in the front like that. Does it have a left node? Yes. So that also goes in the front. That's a 6. Okay. We're going to go through this loop one more time. Node is node if reverse. Reverse is true. So we do a poll last, which is this 2, and add it to the result. Okay. And then deque it. If reverse, reverse is true. So does 2 have a right hand node? Does 2 have a right? Yes, it's a 5. So it goes in the front. Does 2 have a left hand node? Yes. So it gets added to the front. All right. So that's 2 times through the loop, and we change reverse again. Now, I'm not going to go through this whole thing, but you can see what's going to happen here is that reverse is false, here we're going to check that. Reverse false. So we're going to pull from the front, and we're going to pull the 4, the 5, the 6, the 7. None of those have any child nodes. So by the time we use 4, 5, 6, and 7 and add them to the list, we're going to be done. The queue is going to be empty. Okay, so that's how it works. It's a breadth first search with a queue with one twist, and that is we need to keep track of a reverse variable and add Q or deque from the front or the end of the queue as indicated. All right, that should be that should be it. Let me get rid of everything here, and let me just do a quick sanity check on the code. All right, that compiles fine. Let's run it. All right, good. So know how to do breadth first searches. And what else? Please like the video. You can subscribe to the channel. It's free. And we'll see you next time.